In this video, I'm going to explain how to create a complete DevOps CI/CD stack from scratch. This target stack will be a fully functional DevOps framework with working examples of build automation, infrastructure as code, chef deployments, code quality metrics, and various other administrative jobs. So I first started this project as a sandbox to test various DevOps technologies, but as I progressed, I decided to go ahead and automate the provisioning of the stack as well. This way, when I wanted to test something, I could deploy a complete stack into AWS or Azure and then just destroy it when I was finished. Um, so the servers that make up this stack include GitLab, Nexus, Jenkins for continuous integration, SonarQube for code quality, and Chef for configuration management. The servers are not just blank installations. Each server will have already been configured to talk to one another and will be able to perform infrastructure provisioning, builds, deploy, scans, database backups, etc. Uh, my goal here is to be able to take anyone's AWS or Azure subscription info and deploy a fully functional stack with enough chef cookbooks and deployment examples for them to start building and deploying their code immediately. So regardless of if you're using Tomcat, JBoss, or .NET, you'll have working build and deployment jobs for that. If you're using Oracle, MySQL, Postgres, or MongoDB or SQL Server, you'll have deployment examples for that as well. That's including liquid-based build and deploys. So again, as soon as the stack is deployed, the Jenkins server will already have your AWS or Azure client configured. It will already have infrastructure, build, and deploy jobs. It will already have your Knife client set up as well. This means that as soon as the stack is provisioned, you could log into Jenkins, run some Jenkins jobs to spin up a few VMs, and then they'll be automatically bootstrapped to Chef. Then you can just build and deploy. My Chef cookbooks are using Chef Vault, so I don't store passwords or certs in Git, and all of that's handled by the Vault. All of my deployments are written in HA setups, so it's typically a couple app servers behind a load balancer, a couple web servers behind a load balancer, and then clustered databases. The exception to that is the dynamic dev flows, which are just using which are just used to spin up temporary VMs or for testing or scanning. All right, so I'm going to go ahead and kick off this deploy. If you look at the parameters here, you'll see the AWS region, the VNet and subnet info, the access key ID, and the access key itself. The deploy should take about 15 to 20 minutes, and I'll just pause the video while we're waiting for it to deploy. Okay, so it looks like it finished. Took about 19 minutes, which is a little bit slower than I wanted it to be, but that's all right. So right now I'm opening up the Chef server. This is the new Chef server that was just created. You can see the URL up top. Username is dtadmin. That was created during the deploy. Now let's look at Sonar. So for SonarQube, you're not going to see much until we actually do a build. But as soon as I kick off the build, then I'll show you the SonarQube, and you'll see the metrics there. For our Nexus server, there's a few things that was done. There's the Yum repo configs were updated. The Ruby gems was updated. The Ruby gems is actually required for the Chef Vault, and the username and password, obviously. There's a few artifacts here as well that's required for the builds that I'm about to do. And for our GitLab server, there's quite a bit there. The users and groups were created. The SSH key was set up. That SSH info was moved over into Jenkins so that Jenkins can communicate. And there's a handful of repos here. Jenkinsutils for few scripts that Jenkins is running. Our chef has our cookbooks, roles, environments, etc. Infrastructure scripts has AWS scripts and Azure scripts. And there are a few Hello World projects there as well. All right, and now for the Jenkins server, we have a number of jobs here. There's some administrative jobs. We have AWS and Azure jobs for provisioning infrastructure. You can see within Azure, there's create VM, delete VMs, create load balancers, VNet, subnets, etc. For the databases section, each of these directories here has jobs for you to provision, like MySQL, Postgres, MongoDB. The MongoDB one actually provisions a cluster. In that DB backups folder, there's backup jobs for each of those databases as well. Under projects, I have a handful of Hello World jobs for you to you can build and deploy each of those projects. There's one for Node.js, which I'm going to kick off now. So what this is going to do is it's going to spin up a VM in AWS. It'll bootstrap it to Chef. It'll kick off the build job, which will pull from the Hello Node.js Git repo I showed you earlier, and then it's going to convert it to an RPM, upload it to Nexus, send it over to SonarQube, and then it'll deploy it to the VM that was just created. All right, let's see how this is going. It looks like the build finished, so we should be able to see the metrics in SonarQube. And there it is. 1.0.1 snapshot. And here's our RPM and Nexus. And since that VM was bootstrapped to Chef, we should be able to see the node here. And there it is. So this is one of the dynamic test VMs, so it's going to get deleted after 2 hours, and that Chef node will be deleted as well. That's based on a tag when the VM is created. There's a dynamic test tag for those VMs. All right, so the deploy finished. Here's the application. It's a super simple Node.js application. It shows the environment and it shows the release. When setting up this type of environment, there are a few pitfalls to watch out for. When you're working with infrastructure as code, for instance, it's very easy for your VM count to get out of control. In this environment, I'm addressing this by using proper tagging of each resource, compartmentalizing projects into their own resource groups and subnets, and I'm using a scheduled job to delete dynamic test VMs. I've also created some cloud auditing jobs to get clear visibility into the environment. These jobs are particularly necessary for Azure since Microsoft really doesn't provide adequate reporting tools. Another pitfall is to fail to delete resources other than the VM. For instance, someone may delete the VM but forget to delete the NIC or the storage or what have you. I've seen some scripts do this delete operation by assuming a particular naming convention, but my scripts actually query the resource, find out what's attached to it, and then it deletes it. So for Azure, I also have a job that stops the VM and tags it with a date for a retention period. Another job can later search those VMs that have been stopped and tagged and then delete them. Once the VM is deleted, the disks are actually still saved for another retention period. This process prevents resources from being deleted when they shouldn't be, which has happened in in my environments and probably your environments as well. Another issue is failing to delete the chef node and the chef client when deleting the VM. This can pollute your chef database and cause major problems down the line. At some point, you'll likely have to run knife SSH to update all your Linux or Windows machines, but if you have stale nodes in your chef database, the command's going to fail. It'll fail once it hits the stale node. Then you'll have to commit a great deal of man hours to audit your chef database, and this is really bad news if you're racing against the clock to patch against some known malware or something like that. Another big pitfall is when your cookbooks are not parameterized enough or they're not generic enough. So imagine you have a JBoss cookbook that you're using for project A and you decide to reuse it for project B. Your deadline for project B may be based on the assumption that that cookbook can be reused, but then you find out that it's not parameterized enough, and then it needs to be refactored, which affects the timeline for project B and may also affect project A as the change needs to be tested there as well. You can version pin the cookbook in project A, but that's probably just a temporary fix because at some point you'll want to upgrade it to the latest version. The cookbooks in this target environment are well parameterized and have been proven to work in multiple architectures. All those issues I just said, that can also be said for your infrastructure scripts, your build jobs, and your deploy jobs. If written properly, this code should all be reusable. If it's not, your stakeholders may wonder why project B is taking so long when you've already done all this work before. Another unexpected refactoring effort is when cookbooks are not using Chef Vault. If you're not using Chef Vault or some vault, you might be storing passwords and other sensitive information in Git, which is not okay. Refactoring your cookbooks to use Chef Vault and testing them can be a very heavy lift and can introduce some of the same refactoring and timeline issues I just described a moment ago. Another time suck is in identifying workable Jenkins plugins. This is sometimes overlooked, but it does take time. There are thousands of open source plugins, and it's difficult to determine which will meet your needs and which are reliable. I've pre-installed several dozen plugins to solve this problem in this environment, and they all work. Once the target CI/CD environment is spun up, it's ready to roll. So I could go on and on with some of the gotchas I've run into over the years and how much time and money they cost, but I'll describe those issues and solutions in subsequent videos. To recap, this target CI/CD environment includes pre-configured SonarQube, pre-configured Nexus repo, chef server with working cookbooks, roles, environments, and vaults. It includes a GitLab server with several repos populated with working code, and a Jenkins server with working jobs for infrastructure provisioning, builds, app deploys, database deploys, liquid-based deploys, cloud reporting, chef maintenance, server maintenance. It'll have several plugins pre-installed, several dozen plugins pre-installed. It'll already have a pre-configured Knife client, AWS client, and or Azure client. Several of the Jenkins secrets are pre-configured, including the SSH keys for AWS or Azure, SSH keys for the GitLab user, credentials for SonarQube, and some self-signed certs for various app and DB deploys, Hello World app and DB deploys. So I'll create some other videos to demo some of those jobs in more detail. So keep an eye out for that, and thanks for watching.